All right, everybody, welcome back. I am so incredibly pumped you're here for today's explainer because today we are finally going to conquer the ultimate mathematical roadblock. You know exactly what I'm talking about. We are officially entering the gamified math bootcamp, and our mission today is simple: unlocking algebra. So grab your gear, get your head in the game, and let's get ready to level up your math skills.
So here's our game plan for today's bootcamp. 1. The power of algebra. 2. Speaking the math language. 3. Expressions, equations, and formula. 4. Unlocking patterns and sequences. And 5. The high-stakes 60-second function challenge.
Kicking things off with Section 1, the power of algebra, or as I like to call it, finding the why.
Okay, recruits, before we start memorizing a bunch of rules, we need to figure out why we're even playing this game in the first place. I mean, let's be real. It's the exact question every single student thinks the first time they open a middle school math book. Why on earth are there letters in our math? We were perfectly happy just adding and subtracting numbers, right? And then suddenly, the alphabet completely crashes the party. It can feel incredibly intimidating, but there is actually a brilliant reason for this.
We really need to ground these abstract letters right back into reality, because honestly, the letters are just tools. Algebra allows us to take a specific situation and make it completely general, so it works in literally every single case, no matter what numbers are involved. As our sources from the Cambridge mathematics curriculum highlight, algebra is exactly what calculates the absolute best deals at the supermarket. It's the math that engineers use to build bridges so they don't collapse. It's what drives the code of the internet when building websites. And it's the vital link that connects geometry with statistics. It literally teaches your brain to think logically. So the letters aren't there to confuse you. They're actually there to give you superpowers to solve any problem in the real world, not just one isolated equation.
Moving right along to Section 2, speaking the math language. Basically, building your bootcamp inventory.
To actually wield the power of algebra, well, you can't win the game if you don't know what your items do, right? So power-up number 1 is the variable. A variable is simply a letter used to represent an unknown number. Imagine you've got a bag of sweets, but you have absolutely no idea how many are actually inside. Our Cambridge textbook brilliantly uses this example. We just call that unknown mystery amount n. If we happen to take 3 sweets out of that bag, well, we now have n minus 3 sweets. The variable n is really just a placeholder waiting for us to discover its true identity later on.
Next up, power-up number 2, the coefficient. Think of this guy as the sidekick to our variable. The coefficient is the number that multiplies the variable. So, if you see the term 5n, the 5 is our coefficient. And remember, in algebra, we don't bother writing the multiplication sign between the number and the letter. It just gets way too cluttered. So 5n quite simply means 5 times n. Anytime you see a number squished right up against the letter, boom, that's a coefficient, multiplying that variable.
And finally, power-up number 3, the constant. A constant is a fixed number standing completely on its own. It doesn't have a sidekick. In the algebraic phrase 5n plus 4, the 4 is our constant. It never, ever changes. No matter what n turns out to be, that 4 remains exactly as it is. And with that, inventory collected. We are fully stocked and ready to roll.
All right, Section 3, expressions, equations, and formula. Time to practice your combos.
Let's put those inventory pieces together to practice our algebraic combos. You absolutely have to know the difference between an expression and an equation. Honestly, this is a massive stumbling block for a lot of people. An expression contains numbers and letters, but no equal sign. 5n plus 4 is just an expression. It's just a statement sitting there. But an equation contains numbers, letters, and an equal sign. 5n plus 4 equals 19. That equal sign transforms the whole thing into a perfectly balanced scale. What's on one side weighs exactly the same as what's on the other. Let's actually practice translating a real-world problem into these algebraic expressions, step by step. We'll use a classic example straight from the Cambridge curriculum. Step 1, we start with what we don't know. Let's say Matthew is an unknown age. We're going to call his age x. Step 2, we are told David is 4 years older than Matthew. So how do we write that combo? Super simple, x plus 4. Step 3, Ella is half Matthew's age. How do we represent half? Well, we just divide his age by 2. So Ella is x divided by 2. See that? You are literally translating English directly into the language of math, building expressions from real, everyday sentences.
Which brings us to Section 4, unlocking patterns and sequences. We're prepping for the boss battle now.
You guys are doing great, but the challenges are definitely getting tougher. We're going to use the tools we just learned to find the hidden code in numbers. Sequences are literally just predictable patterns of numbers. and algebra is the ultimate tool for cracking them wide open. First, you identify the position number. Is it the first number in the line, the second, the third? Then you find the rule. Take the sequence, 3, 6, 9, 12. You can easily see it's going up by 3 each time. But algebra lets us generalize this relationship so we can find, say, the 100th term without counting on our fingers forever. Because the first term is 1 times 3, and the second is 2 times 3, we can say the nth term rule is simply 3n. Just multiply any position number n by 3, and boom, you have your exact number.
And here we are, Section 5, the 60-second function challenge. Time to beat the clock.
All right, boot campers, this is it. Everything we've learned, variables, rules, patterns, it all comes down to right now. The clock is officially ticking. Your job is to figure out the algebraic rule turning the input into the output. Sourced straight from a Cambridge workbook, let's look at the data. When the input is 10, the output is 1. When the input is 23, the output is 14. And when the input is 34, the output is 25. Think about the relationship between the input column and the output column. It is the exact same rule every single time. What is the machine doing to the variable?
You've got 10 seconds left. Come on. Is it multiplying, dividing, adding, subtracting? How do you get from 34 down to 25 using a single constant? And remember, you have to use the exact same logic to get from 10 down to 1. Got it in your head? Lock in your answer right now.
And time's up. The algebraic rule is n minus 9. Yes! If you take the input variable n and subtract the constant 9, you get the output every single time. Let's check it. 10 minus 9 is 1, 23 minus 9 is 14, 34 minus 9 is 25. If you nailed that, huge congratulations. You have officially conquered the Algebra Bootcamp.
Level absolutely complete. You've successfully unlocked the foundational power of algebra. As your well-earned reward, make sure to hit that like button, share this explainer with a fellow bootcamper who might be struggling with all those letters in their math, and subscribe to the channel so you never miss our next rigorous brain-boosting breakdown.
But hey, before I let you log off entirely, I want to leave you with one final provocative challenge to really test those newfound skills. If the function x is transformed into 2x plus 3, and the final output is 33, what was the original input? Think about how to work backward. Think about the balance of equations, like that perfectly balanced scale we talked about earlier. Work it out, drop your answer in the comments below, and let's see who gets it first. Thanks so much for watching this explainer, and I'll catch you in the next one.